Hello and welcome to the YouTube channel D Creations Resources. We are looking at different concepts of science. We have been speaking about Hall effect, and in that we spoke about drift velocity. So let us understand the concept of drift velocity. So you can imagine that there is a room, a crowded room full of school students. Now, as you know, young school students are very active, so they are all the time moving here and there in all directions. So this is their normal movement, so as to say. Now imagine that a teacher opens a door and instructs them that everyone has to start coming out of the door. So now these school kids will still be pushing each other or moving about in that way, but they are also moving slowly towards the door. So this slow overall movement in one direction on top of the random bouncing and pushing each other is called, or rather is like, drift velocity. Now obviously here this is just an analogy, so we are talking about electrons. So consider now a wire, and inside a wire, so instead of a room, consider a wire. And now imagine the situation that there is no voltage applied. So now the tiny electrons are just constantly jiggling and moving in random directions. But now if you apply a battery to that, that means you are kind of channelizing these electrons to move in a certain direction. So due to this push from the electric field, the electrons, although they will keep bumping, they will start moving towards the direction that is given to them by the push. So this slow average speed is the drift velocity. Now here, even though each electron is moving slowly, there are several electrons in a wire. So all these tiny slow pushes together will create the electric current, or it will generate the electricity that is going to power your electrical appliances. So drift velocity is like the tiny slow steps of a huge crowd of electrons all moving in the same general direction when electricity flows through a wire. Now to talk in technical terms, drift velocity is the average velocity that charged particles like electrons attain in a material due to an electric field. So it is the slow net motion of these charge carriers superimposed on the rapid random thermal motion. Because as you know that in the wire, the electrons are going to be moving randomly at high speeds due to their thermal energy. And these movements are going to be in all directions, and their average velocity in any specific direction is zero when no electric field is applied. Now when an electric field is applied, or when a voltage is applied across this wire, an electric field is generated basically. So that electric field is what I am talking about. This electric field is going to exert a force on the free electrons, causing them to accelerate in the opposite direction to the field, because electrons are negatively charged. And as these electrons accelerate, they collide with the atoms of the material's lattice. These collisions disrupt their motions, causing them to lose some of the kinetic energy gained from the electric field and change direction randomly again. So if you talk about the net drift, despite the frequent collisions and random motion, the electric field continuously accelerates the electrons between the collisions, resulting in a small average velocity in the direction opposite to the electric field, and this average velocity is the drift velocity. And this drift velocity is a product of certain terms. Which are these terms? It is the current flowing through the conductor, then the number density of charge carriers, that is number of charge carriers per unit volume, the cross sectional area, and the charge of each carrier. Now the drift velocity can also be explained in terms of mobility. So drift velocity is product of mobility and electric field. And what is mobility? Mobility basically represents how easily electrons can move in a material under the influence of an electric field. It's measured in meter square per volt second. So to summarize, drift velocity is the slow average motion of charge carriers in a material due to an electric field superimposed on their much faster random thermal motion. Now, it's a fundamental concept when you try to understand electrical current, conductivity, and even in the Hall effect, we are talking about this drift velocity when you talk about Lorentz force, for example.